This tutorial is about cleaning data. So once you've defined your population, defined your sample, defined the quantitative variables, the qualitative variables, and proposed your questions, the next thing is to look at the data set, the sample data set that you've been given, and to see if cleaning of the data is necessary. And why do we need to look at cleaning of the data? Well, it makes the data fit for purpose and plausible. It reduces the negative impact of error. So when we're looking at the summary statistics, by removing obvious data points that are not correct, that interferes or reduces the interference or bias that might be added by having incorrect data, and it improves the quality of the data and the quality of your deductions that you can make about the summary statistics. And so the cleaner your data, the better the sample data, the more reliable your data will be. However, there is a caveat here. Do not clean the data unless you really can justify the reason. So you must be, when you clean, if you clean any data point, you must write down that data point and you must state why you are cleaning it. Now, what sort of things would you be looking for? Well, any non-response. Anything that's left blank or has no data point in it, you clean and you remove. Any missing data, you remove that, because they will act as zeros and they will change your means, medians, modes, etc. Any obvious data point that's incorrectly recorded. So, for example, if you're talking about kilograms of the weight of people in kilograms, then 4,200 kilograms is not a common mass. So you would delete that. If you're talking about height, and we're talking about it in centimeters or even meters, 1 centimeter is not a valid. There's nobody, not even a newborn baby, who has a height of 1 centimeter. So you would remove those sorts of data that are clearly recorded wrong or that clearly misrecorded. So 4,200 grams or 42 kilograms would be correct. So you would remove that point. Check your zeros. Are they truly zero? Is that a valid zero value, or are they just not recorded correctly? And if they're not recorded correctly, you can take them out. Do all your quantitative variables have the correctly stated units? If not, you remove them. Manual entries, switching of numbers around, missing numbers, inputting wrong response, duplicate responses. These are hard to figure out from most of our data sets, but sometimes you can pick up on them. But the rule is do not remove them unless you can genuinely state why you would remove them. So the process is to detect, resolve, treat, and only clean the data of a value if you can justify its removal. And I think that's the main point. So what I'm going to do now is go to New Zealand Grapher. I'm going to upload one of the data sets that we can use here. Oops, that's the wrong data set, so that obviously can't be used. So I'm going to go back and choose a data set. Okay, so I'm going to have to open up Google Docs here. So I'm going to go so I'm going to just cancel here. I'm going to open up Google Docs for the time being. So I'm going to open a new window. I'm going to go to Google Docs. I'm going to go to the 11 Math external folder, and then I'm going to go to the datasets, and I'm going to now just download that to my desktop. I'm just got to wait for it to come up. When it's downloaded onto my desktop, I can so here I'm going to save this to my desktop, and then I'll import it. Note I've saved it as a separated comma values. I'm going to click out of there, and then I'm going to go back to New Zealand Grapher, and I'm going to choose the file. I'm going to go to the desktop, and I'm going to choose the file, and here we have it. And I'm going to look at the index finger values. These are recorded in millimeters. So the ones that I would think that you seriously should think about, this 5 here. 5 millimeters is very short. It's not even 1 centimeter. It's half a centimeter. And people with index, it could be that they've got a chopped off index finger. That could be. But note that these are all, this 0 definitely needs to be clear because there's no one. And you'd have to have amputation, and very unlikely. So I'm going to clean that. I'm going to clean that, and I'm going to write in my Y. I'm going to justify that. I'm going to look through. So this one down here at 7, I'm going to clean that. I'm just going to make an arbitrary statement that I want them recorded over, and this could be 8 centimeters, and it's been recorded as millimeters. This 0 here again, I'm going to remove. This 350, that's a very long index finger, and I do not think that that's valid. I will justify that to say 35 centimeter index finger just is way out of whack with the rest of the data, and I would clean that. So you've really got to have good reason. So anything under 20 centimeters, unless I know that the person does have an amputation of some description. So this, and anything in the hundreds, 10 centimeters or more. Now some pianists have long fingers. Some of the international pianists have really, really long fingers. And there's a 209, that's 29.6 centimeters, and that just doesn't make sense to me. And this 5 centimeter here. So now I'm going to save the changes. And note now what happens when I, so I'm going to do a box plot. I'm going to use as my, I'm going to use index finger in millimeters. I'm going to use gender, and I'm going to put in the summary statistics and box plot. And there's still one down here under 10, which I think said all of these are at 30. So I am actually going to try and find where that 10 is, and I'm going to remove that. That's 1 centimeter. And I'm going to resave that. So I'm just going to scroll up, and I'm going to, but the most important thing is you must justify why each one of these was removed. So let's see if we can find the 10 centimeter in the index finger here. So there's one here that's at 100. And there's some more at 100. That's 10 centimeters. Does fit in with the 90, so I actually have to say I probably would leave that one, but I'm definitely going to try and find the 10 centimeters and 10 millimeters and remove it. 10 millimeters, where are you? 10 millimeters. There's one at 8. I'm going to save that change. And that, yep, that brings it there. So all the data points are between 28 or so, and so I can't really justify the removal of these ones up the top, and I can't justify the removals of these ones down the bottom. We note that the median here is 70 and the mean is 74, which means there's a little bit of skewing in the data, and we can see that this does not have, the median and the lower quartile are the same here, whereas there's some skewing here also, 75, but it's not that bad actually there. But that's about all I can justify. Note that all the removed points are recorded here. I just have to now go ahead and state why I removed all of those. So clean the data only if you can really, really justify removing the data. Record the data points that you remove and justify why you removed them. They'll give you better results. Just to show you what would happen to this set of summary statistics if I go back and re-import the original data and I redraw the graph just without, so I'm going to go here and I'm going to find index finger, and I'm going to find gender again, and I'm going to put in the summary statistics in the box and whiskers. Note now what happens to these values here. These two values up here and these ones in here are potential outliers, and they really are going to skew the data. And so now we've got a median of 70 and a mean of 73, and these ones here, these 0 values down here are really pulling the mean low. Outliers affect means more than they do medians, and if you leave in some potential outliers because you can't justify, you should really use your median as your central measure of central tendency rather than the mean. Mean is the best if you've got a nice even distribution, but median should be used if you've got noticeable extreme values, I'll call them, because here's an extreme value, a set of them down in here, and a set up there. Okay, that's a video on cleaning data.